Hi, welcome back to my YouTube channel. In this video we're gonna see how we should solve this demon looking integral that has a differential operator in its power and a stranded -1 here. Usually these types of integrals are like this, x minus 1 dx, but here we got dx in the power and a -1 is stranded here in front of integral. What I can do here is we can say x to the power of dx minus 1 is the same thing multiplied by dx over dx. Keep in mind that dx is very small change in x and dx approaches 0 and is infinitely small change in our x, and you might have seen it as delta x, where delta x is very small. So x to the power of dx minus 1 over dx. Now it makes our work more simple, so we gotta just use this term here, and we just wanna calculate the term here. X to the dx minus 1 over dx. What is this expression equal to? If I take the limit of both sides as dx approaches 0, x to the power of dx minus 1 over dx, I'm gonna be left with x to the 0 minus 1 over 0. 1 minus 1 over 0, which is 0 over 0. So this discontinuity can be removed. So how should we remove this discontinuity? So my limit as dx approaches 0 of x to the dx minus 1 over dx. What I'm gonna do here is I'm gonna take the limit of both sides with respect to dx, but in here I'm gonna just call this dx h for convenience, as h approaches 0, x to the h minus 1 over h. You might remember h to be your formula from your calculus limit definition, but because they're very similar concepts, here our dx and changing a small x is approaching 0, and in our the derivative definition by limit, we want to find the slope when the change in x is very small. So what I can do, I can take the derivative of both of these, both numerator and denominator here with respect to h, x to the h minus 1 over ddh of h. Limit as h approaches 0 of ddh x to the h minus ddh of 1 over 1. ddh of h is just 1. So limit as h approaches 0 of this, so ddh of 1, derivative of 1 is 0. I'm gonna just cross it out with red. Now we're just left with okay, so changing ddh of h to the x to the h is x to the h ln x, according to the definition of the power functions differentiation, exponential function, sorry. So I can say that it is x to the h ln h. Now I've removed the discontinuity, I can say that limit as h approaches 0 is x to the 0 of ln x. This should be x, which is ln x. Thus, we concluded that x to the dx minus 1 over dx is ln x. And I can go back and plug it in this integral. So what I'm going to do, I'm going to write this integral again. So it's going to be ln x. So this expression here is gone, and we're left with a dx, ln x dx. We should differentiate the ln x right now. So I is gonna be, we're gonna do differentiation, integration by parts. So ln x is gonna be my u, and my dx is gonna be my dv. Let me create more space here because I'm gonna need it in the future. So integration by parts, u dv says that if I have a function u defined as u dv like this, it's going to be uv minus v du. My u here is ln x. Du is 1 over x dx. My dv is dx, thus v equals to x. So now, what I'm gonna do, I'm gonna integrate this function by parts. So my I equals to my ln x times v times x minus v du. V is x times du. My du is what? My du is 1 over x dx. I therefore is x ln x minus dx. The dx integral is just x ln x minus x plus c, some constant of integration. Thus, our integral of x to the dx minus 1 is x ln x minus x plus c, some constant of integration. So hope you enjoyed this video. If you have any questions, please let me know in the comments, and I will see you in the following next videos.